Hey everybody, Professor Davis here from ChemSurvival.com and the YouTube channel ChemSurvival to show you the mechanism of catalytic hydrogenation of an alkene. So what I'm showing you here is essentially what happens when you take an alkene and mix it with hydrogen in the presence of a catalyst, which is usually something like palladium or platinum on carbon. So the carbon's really just there to hold things up, and the platinum and palladium metal is coated along the outside. It's very expensive, so we only need a thin coating of it, and so the carbon sort of provides some volume there so that we can create a lot of surface area with a small amount of platinum. So we're going to take an alkene and a hydrogen molecule and react them. But the reaction takes place at the surface of this catalyst. Now the first step in this process is that the hydrogen molecules will break apart into neutral hydrogen atoms on the catalyst surface. Now, what's important about this is that this means that those hydrogen atoms are held in space on that catalyst. They can't move until they have reacted with the alkene. So the next step here is that the alkene double bond also interacts with this catalyst surface. And so the alkene comes in like this and attaches itself. Now, the final part of this process is that our alkene is going to pick up those hydrogens. And when those bonds form, they have to form on the same side of the alkene because the hydrogens are both held on the surface of the catalyst that's holding it. So on both sides of our bond, we'll be attaching hydrogens at the same side of the molecule. Finally, because they've created new bonds to the hydrogen atoms, this new saturated compound is no longer going to adhere to the surface and will fall off. And when this happens, we get the completed reaction with our new hydrogenated compound. Now, what's most important to understand about catalytic hydrogenation of alkenes is that it produces the syn addition product. That is to say that the hydrogens have to be added to the same side of the molecule. Now, in my example here, where we have a completely symmetrical alkene, this is absolutely unnecessary to understand. However, when we start working with unsymmetrical or asymmetrical alkenes, it becomes incredibly important to understand because it will affect the stereochemistry of the products. And we'll talk about that in another video at another time. This has been Catalytic Hydrogenation of Alkenes. I'm Professor Davis, and thanks for watching. I'll see you next time.